Okay. Assalamualaikum and hello guys. Today our group will present about a projectile motion in football. Okay. This is our team. First of all, I'm sure that most of you have watched a football match, right? Okay. Now I want to ask you a question. Have you ever imagined how the player can pass the ball to their teammates so accurately? And does it has anything to do with physics? The answer is yes. When the ball was kicked with a certain angle, the ball moving in vertical and horizontal motion, and this motion was called projectile motion. Thus, the ball will have a vertical speed and horizontal speed. This situation was called kinematic in two dimension. Okay. This is our topic. Okay. Our objective is to determine the maximum height of the ball that was kicked from the ground with a certain angle. To determine the kick. Secondly is to determine the kicking speed needed by the player to make sure the ball reached his teammate.
Projectile motion in football. Our world is three-dimensional. For easier analysis, many motions can be simplified to two dimensions. For example, an object fired into the air moves in a vertical two-dimensional plane. Also, horizontal motion over the Earth's surface is two-dimensional for short distances. Elementary vector algebra is required to examine the relationships between vector quantities in two dimensions. So here are some of the equations used horizontally and vertically. Here are the examples in projectile motion in football and how to solve it. Given that a player kicks a ball from the ground with an angle of 40 degrees to his teammate. Given that, time for the ball to reach his teammates is 6 seconds, and distance between the players is 50 meters. Here we need to determine the initial speed of the ball and determine the maximum height of the ball. Okay, to determine the initial speed of the ball, the equation used is sx equals to uxt plus half axt squared. But here, the equations is only sx equals to uxt because of the ax is equals to 0. So, sx equals to uxt. So to find the u, we need to divide sx with t, and then we get the 8.33 meter per second. And this value is the ux, or the speed for the horizontal. And to calculate the initial speed of the ball, we need to use the cosine for t equals to 8.33 over u, which is the initial speed of the ball. And then we just plug in the value and we got 10.9 meter per second. So 10.9 meter per second is the initial speed of the ball. For the next part, to determine the maximum height of the ball, we need to know some crucial point here, that in maximum height of the ball, the Vy is equals to 0 because the ball is not going upward or downwards. So the most suitable equations that we can use is Vy square of equals to Vy square minus 2gs. So we just plug in the values we have, and this maximum height of the ball is 2.5 meter per second. And to calculate the speed for the vertical or y direction, we just need to use simple trigonometric equation, which is sine 40 equals to ay over 10.9 meter per second, and then we got the 7 meter per second.
The example of the projectile motion. Okay. Look, the player passed the ball to his teammate, and the second illustration is the motion of the ball. The when the ball reach a maximum height, the velocity is equal to 0. That's all from us. Thank you.